From eggs to ice cream, supply chain. Where eggs are being produced on a national scale. 36.1% of federal egg quota in Canada is Ontario, Quebec at 19.7%, the Western provinces and Northwest Territories combined, 36.8%, Eastern provinces, 7.4%. Where eggs are being produced on a farm scale. There are 4 main systems to house hens. 1. Conventional housing. Small group settings that enables equal access to fresh food and water. 2. Furnished and enriched housing. Includes perches and a curtained-off area to give hens privacy to lay eggs. 3. Free-run housing. Access to the entire barn floor area to perch, scratch, forage, and lay eggs in nesting areas. 4. Free-range housing. Access to the outdoors, weather permitting. A step-by-step process on how eggs are produced. 1. Hatching and placement. Egg producers purchase layer stock from an egg-type hatchery. Hatcheries deliver chicks to producer within 1 to 2 days of hatching. At arrival, chicks are either placed in a typical layer pens or reared in a pullet house. At the hatchery, chicks are vaccinated according to the producer's specifications. 2. Lighting and temperature. Daily light exposure begins to increase at week 16. This increase in light exposure triggers hen to begin laying eggs. 3. Feeding. Feed is generally offered to birds through a chain system. Young birds are fed a high-protein diet, but decreases until it reaches approximately. 4. Egg production. Diet manipulation for optimal egg production is 18 weeks of age. Minor nutrients are manipulated. Calcium levels in the diet are approximately 5 to 7 times greater than phosphorus levels. Hens reach peak egg production around 30 to 32 weeks of age. Post-peak egg production, often after 30 to 32 weeks of age, decreases to approximately 50% around 60 to 70 weeks of age. Majority of hens are between 100 to 130 weeks of age when they reach the end of their egg production cycle. 5. Egg collection. In layer facilities, there are 2 primary methods of egg collection. The first method is inline facilities. Eggs move directly from the layer house to the egg processing facility. They are then washed and graded for packaging, and are moved to a cooler room where they await shipment for retail outlets. The second method is an offline facility. It functions identically to the inline facility, except that the eggs are transported out of the house directly to an egg cooling room. In 2019, the average price to the producer is $1.96 a dozen. The grading of eggs. Transporting from farm to grading station. Eggs are transported from the farm to the grading station. During the journey, the eggs are stored at 10 degrees refrigerated, hygienic conditions to prevent bacteria from proliferating. They are kept in a shrink-wrapped pallets. Moreover, the trucks and trailers can't carry substances that can have adverse effects on egg quality. Also, a person who ships or transports eggs within Ontario shall carry at all times with the shipment and bill of lading, which shall show a. the name of the address and grading stations. There are 4 types of egg grading stations in Canada, which differ in terms of labor and technology use, listed as follows. 1. Shared. 2. Mobile. 3. Community, which is medium scales. 4. Community, which is high sales. Grading process. Washing. As soon as the eggs reach the grading station, the eggs are washed and cleaned in water having a specific temperature and pH balance to get rid of residues and pathogens on eggshells. Candling. The eggs are now sent to the conveyor belt, which carries the eggs forward and rolls them under the bright light in a dark room. All internal defects and cracks can be detected, and by using sensors, the eggs are graded. Weighing. Eggs are weighed and sorted according to size and category for Canadian A grade eggs. Packaging. Grade A eggs are packaged in cartons, while grade B and C are carried to the processing plants. There are 4 egg grades in Canada: A, B, C, and Canada Nest Run, and they are classified according to their interior quality, shell quality, and weight. Selling. Grade A are sold as the common table eggs in retail stores. Grade B are sold mostly to bakeries, also sold to the processing plants which manufacture ice cream. Grade C and Canada Nest Run are sold only to processing plants. How does it work? Supply management system connects total supply to demand and divides the right of producing eggs, which are called quota. The quota system is controlled by the Egg Farmers of Canada at the national level and by Egg Farmers of Ontario at the Ontario provinces level. It keeps the supply and demand statistics relatively constant. Ontario egg producers currently own 37% of federal quota, which amounts to 325 farmers. Egg Farmers of Canada's statistics are as followed. 75% of eggs are grade A table eggs, while the rest are eggs used for further processing, to be used for both edible and inedible products. Separation of eggs. Value added is in the labor of separating the egg. There is 100% no salmonella and other pathogenic bacteria. It implies a complete mindset and attitude change for the company, from being a mere producer to transforming into a processor. In other words, they have to move from the farm to factory, from agriculture to industry. A compact line can be easily removed and easily traded because it is as one piece plug and play system. A working unit which can easily satisfy the needs of many other investors looking for the same solution at startup. Several liquid egg producers have run into serious financial problems because they have failed to produce good quality products. This is a typical problem. It is not related to the bad engineering of the plant, but simply to the small production size. To ensure quality, there is a basic optimum quantum required for production. If the market is unknown, the best alternative is to invest in a fully flexible line which allows production of a number of egg products, including separated eggs and with salt or sugar mixes. Normally, the most common and simple product to offer the market is whole liquid egg. But later, as consumers become loyal to the brand and service, they are likely to explore more specific preparations and mixes to improve their recipes and processes. How eggs are processed. By breaking and separating the egg, you can turn your consumer eggs into highly valuable pasteurized liquids and/or dried egg products, suitable for endless number of industrial uses. The part of the egg in an ice cream is the yolk. There are 2 methods of egg handling and loading. The first one is fully automatic unloading of eggshells. A fully automatic robotic arm can be used that gently unloads the egg stacks from the pallet to the in-feed conveyor, the capacity of up to 216,000 eggs per hour. The second method is the egg stack and tray lifting device. Designed to handle stacks of 30 egg trays by using the ergonometric balancer that has the capacity for lifting up to 75 kilograms. This can handle 4 stacks of 6 trays in each movement. Washing, breaking, and separation. The loading of eggs can be washed and separated. Egg breaking and separation. Clean albumin and dry yolk with the low bacteria count are basic ingredients for producing premium value-added products. This is true whether you are pasteurizing or spray drying your standard or specialized products. This means that every single egg must be carefully broken, drained, and separated, leaving the egg shells as dry as possible. Liquid egg processing. Immediately after breaking the yolk, albumin and whole egg must be filtered and cooled. Tests have shown that filtering immediately after breaking does not affect the bacteria count or increase the risk of contamination. The cooling of egg products. To keep the growth of bacteria at a minimum, the raw egg products must be cooled to a temperature below 4 degrees Celsius as quickly as possible. Standardization of egg products. In the production of egg products, whether it is liquid or powders, the raw material must be standardized within defined specifications. The purpose of standardization is to obtain the same balance between different parameters like water content, fat, protein, and carbohydrate, and also pH. The egg yolk should have as high a dry matter as possible, but due to differences in raw material, production speed, etc., a standardized average needs to be set, which could be 44% dry matter. The level is adjusted to either whole egg, egg white, or yolk with a different dry matter. Ice cream production. Ice cream is generally composed of greater than 10% milk fat by legal definition, and usually between 10% and as high as 16% of fat in some premium ice creams. 9 to 12% milk solids, non-fat. This component is also known as serum solids. It contains proteins and carbohydrates found in milk. 12 to 16% sweeteners, usually a combination of sucrose and glucose-based corn syrup as sweeteners. 0.2 to 0.5% stabilizers and emulsifiers, and lastly 55 to 64% of water, which comes from the milk or other ingredients. The original emulsifier used was egg yolks. Now egg yolks, egg yolk derivatives such as lecithin, or synthetic emulsifiers and stabilizers are used. Synthetic emulsifiers can be cheaper than egg yolks and egg yolk derivatives. Emulsifiers are used to help keep the milk fat evenly dispersed in the ice cream during freezing and storage. A good distribution of fat helps stabilize the air incorporated into the ice cream and provides a smooth product. Organic and artisan ice cream will use yolk. Organic standards require that egg yolk or natural egg yolk derivative are used. Synthetic emulsifiers are not allowed. Classifications such as organic and/or artisan can add more value as compared to ice creams that only use synthetic emulsifiers, as they can be considered premium products. Marketing and added value. Ice cream can be called custard or French if the content of egg yolk is at least 1.4%. Prices of French vanilla ice cream can be double that of regular vanilla ice cream. Listed below are some brands that typically use egg yolks as an emulsifier, and some that do not. The basic steps for manufacturing ice cream is blending the ingredients, pasteurization, homogenization, aging the mix, freezing, packaging, and hardening. Value added to the final product is determined and increased based on the brand name, the type of packaging, shipping, and case dimensions, and the pricing in the market.